Great. Okay, I think everything is recorded. Thank you for joining everybody for this August 10th, 2023 webinar on broadband technologies. We do have a lot of information that we're packed in here. We have three excellent speakers. So I'm going to just provide a brief overview and then mostly be monitoring the chat, as Mike said. I'm hoping this, to have kind of a more robust Q&A at the end. So anytime a question kind of arises, feel free to put it in the chat and I'll capture it and kind of moderate a little discussion at the end. So before we kick it off to our presenters, I just wanted to very quickly set the stage in a way that I've been doing over the past couple of months as part of the Illinois Broadband Labs listening tour, which is just a very, very brief overview of what we're talking about when we're talking about broadband. Internet connection, broadband are used pretty interchangeably nowadays. It wasn't the case in the early days of the web in the early kind of mid-90s. So what distinguishes broadband from just general internet service is that it's an always-on connection. So if people are experienced enough to remember the weird sounds of a modem connecting to the internet and all those sorts of things, that was generally a pre-broadband, whereas now it's generally just the always-on type of connection that you have when you get onto the internet. The reason I really like this graphic, which comes from Connected Nation, is that it shows pretty succinctly the different ways that people connect, the different technologies that people use. And so on the top, you'll have wireless connections. The bottom, you have wired connections. You can see too on the right, it sort of goes from faster-ish speeds, in more urban dwellings and stuff on the left, and then farmland on the right. So very, very quickly, mobile broadband, most people connecting via your cell phones. Fixed wireless has it's high location, sometimes water towers, and then satellite roaming wireless connectivity. At the bottom, cable wires, either strung up aerially or underground, fiber underground typically, and then DSL, kind of old telephone phone lines that people used. But a big emphasis that I like to point out is that in some way or another, all of these technologies eventually go to fiber, and you'll learn more about that in today's presentation. In addition to the specific technologies, speeds are also a big component in what we're talking about when we mention people having different levels or access to broadband. So these are the definitions that Illinois and others use to determine what is or isn't broadband on certain maps and for certain funding requirements. So unserved is anything under 25 megabits per second download and 3 megabits per second upload. You can see by this graphic that's generally only gets you enough kind of bandwidth for two people to kind of simultaneously use the web. Then you kind of move up into that underserved, where you have 25 down, if you're in between that 25 and 100, talking about download speeds, that would be considered underserved. And then served is kind of where we're trying to get every household, community anchor institution, everything else across the state to that service level, which is 100 megabits per second down, 20 megabits per second up, which would enable, generally speaking, 5 users, so a family to be able to kind of comfortably use the internet in their home. This is another slide that says that information. I know there's a lot on here. The key thing that I just want to draw attention to is the uses at the bottom, and really start kind of recognizing, yes, there are some households where the use might just be streaming or kind of general web browsing or email, but video gaming, government uses, different commerce, different work or health applications, these might require different speeds and different upload speeds. So face-to-face video, for example, is going to require higher speeds than just sending an email to somebody else like that. So that's a very brief overview of generally what we're talking about when we talk about broadband technologies and speeds and what's useful. But I'm going to spend the rest of the time kind of listening to our experts and monitoring the chat. And again, please feel free to ask any type of question in the chat and we'll try to answer that. And so with that, I'm going to hand it over to Mark Thorson to talk a little bit about his work at NIU.
Thank you. Give me 1 second. I'm going to share my screen and hopefully this works. I'm bringing up the PowerPoint version of it. So. Okay, hopefully everyone can see the slide for broadband. All right. First off, my name is Mark Thorson, as Ravi said, and I'd like to thank the U of I Extension Program, the Benton Institute, the broadband folks over at DCEO, and also my iFiber team, Joe, Jen, and Lance, who are absolutely instrumental in being able to provide this work and be able to have this service available. So with that, sorry, I'm trying to switch slides. There we go. Just a brief overview of what I'll talk about. Just an introduction on me and the project of iFiber. So there's some definitions that I think would be important for understanding some of the material I've got, as well as what broadband looks like today. And I'll wrap up with what open access networks are and why I think they're incredibly important. So very quickly about me, I've really been a local IT guy for well over 23, 25 years. I've worked for 3 different municipalities prior to joining Northern Illinois University. One thing to know about me, I'm a huge advocate of shared services. I think it's absolutely critical for local government up to county government to figure out ways to share resources as revenue streams are not necessarily growing, and but expectations are growing for communities. So back in circa 2010, NIU worked with community leaders and led a charge to apply for FCC grants in order to create a rural broadband network. So this grant was for fiber optic network cable to be installed in areas outside of more urban locations. And in the end, we ended up creating a network that starts around Boone and Winnebago County and stretches west to the Mississippi River. And from the Wisconsin border goes to about 2 counties south. So that's just an idea of the footprint that we've been able to develop and connect community anchor institutions, as well as foster economic development in those areas. NIU's role in this is we support that iFiber project through sales, accounting, business office, project management, engineering, inside and outside plants, and any other work that's required to be able to make this project a success. So NIU did create Illinois Fiber Resources Group, which is a nonprofit. We typically call it iFiber. All right, very quickly, some definitions. Last mile is essentially that last bit of connection, whether that's fiber, whether that's copper, wireless, whatever that point of distribution for an internet service provider to the home or residence, business, or other building. We typically call that segment of the connection the last mile. So when you hear folks talk about, oh, this project covers last mile into communities, that means that they are actively connecting homes and businesses, buildings through whatever that project is. Middle mile, on the other hand, is really more on the internet service provider side. And it's typically used to connect between where there are meet-me's, where you have 2 different ISP companies together and connecting to each other out to their distribution points, heading out to communities. So you can sort of think about this as the connection between communities, between states, between regions. All of those would be considered a middle mile connection. Symmetry is really what Robbie covered earlier, which is when we talk about 25 megabits per second download and 3 meg per second uploads, that is an asymmetrical connection. A lot of our residential connections are asymmetrical. You have faster download speeds typically than you have upload speeds. Higher cost presentations or services are symmetrical, which means if a customer pays for 100 megabits per second, they are getting that both download and upload at the same speeds. Tier grouping is not something I'm going to dive too far into, but it does explain something that I have, a diagram I have in a couple slides. A tier is just basically a level or a rating of an organization in an industry. What gets confusing is tier 1 means the highest level when we talk about internet service providers, but it means the lowest level when we're talking about data centers. So it's a bit confusing, but I wanted to just explain that it is really just a grouping of organizations that have achieved a certain rank or rating. And so we call them, that group, a tier. And last but not least, data centers and internet exchange points. The one word or phrase I don't have on here is carrier hotels. These are essentially physical buildings, and there's very little difference between them, other than data centers typically have more services available to the tenants that are in that area, where internet exchange points and carrier hotels are a bit more streamlined to, I want XYZ service provider to connect to ABC service provider. So creating those connection points is kind of the focus of internet exchange points and carrier hotels, while data centers will offer more services like access to high-speed computing and other things. So I'm talking about open access and why it's important, but I sort of want to take a step back to that to explain why. Why would we need it? What's the state of today's broadband look like, and what can this address? So some of the challenges that are in today's broadband within the US is we have a situation where broadband has grown out of the telecom industry. So a lot of the telecom industry rules and regulations after AT&T was deregulated and the monopoly was divested, there were rules set up for telecom providers to be able to work. Well, these rules have sort of extended into what we look at for broadband and internet service providers. The challenges with that is some of the legacy rules and regulations may not be meaningful. Sometimes there are hurdles for entry. So there's definitely some I think, initiative to look at those and understand how internet has evolved and why, how we can change that industry so that it can be more business friendly and also more community friendly as well. Right now in the US, we have a large area of regional monopolies. So these are areas that only have one provider that serves that community. And that obviously is a challenge for customers and businesses to be able to look at choice and have that ability to see if there are other options that are available. And as we start seeing more from a wireless perspective, a satellite perspective, and more builds in broadband for fiber, I think that we're going to start seeing that more competitions going into these communities. But that's an area of a challenge for right now. And finally, overbuilds and scarcity. So just speaking generally, high density and high income areas have a lot more build and a lot more competition. Lower density and lower income areas have more scarce capabilities and services. So with that, just focusing in on the overbuilds area, we have communities right now that are really looking at what is in their utility easements and understanding, because there is no requirement for companies to go back and pull out dead infrastructure. So we have a lot of abandoned infrastructure as well as new infrastructure and overbuilds happening, which is tying up easements, which puts communities into a situation where they've got to figure out ways to manage this. So we want to be able to find ways to help communities with that as well as build into the areas that are more scarce. I wanted to show you this slide because just to build off of the slide that we saw earlier, to diagram how we connect. This sort of focuses on the internet providers that we typically have, and then what the internet actually looks like. So working from the outside in, we have our end user customers. They typically connect to some internet service provider in some fashion, whether that's through cellular, fixed wireless, copper or fiber in the ground, and satellite services. From there, you're either connecting to what's considered a tier 1 internet service provider or a lower tier internet service provider that's more regional or smaller. Those providers have to connect to somewhere. So they usually send back to some data center where they can do a meet me with a larger tier 1 provider as a handoff. From there, the tier 1 group is just the largest internet service providers in the world. And they have an agreement that they do not charge each other to connect. So we call that a peered network across the world. Those tier 1s can attach to each other at no cost. However, they make their money by either end customers connecting to them or through regional service providers paying fees to connect to them at some point. So this just kind of takes a step back and gives you a real high level view of how the internet works, and just sort of give you the physical infrastructure behind it. The carrier hotel data centers, these are tier 4, that's the highest level. There's only a few of them throughout the country. One's in Chicago at 350 Cermak. There's one in New York, one in Los Angeles. The large cities have these. Not all states and not all cities have a tier 4 carrier hotel. So these internet exchange points start to become important by facilitating those connections outside of those regions that are further from those major carrier hotel data centers. What is open access? So in the shortest sense, it is a network that is typically owned not necessarily by an internet service provider, but by some third-party organization, be that private company, nonprofit, or municipal. And that network is assets in the ground that are maintained by that organization and are free to be used by any internet service provider that wishes to partner. So the idea behind open access is we have these assets in place, we open them up to internet service provision through another company. They provide those services over that same fiber network or typically whatever that connection looks like. This can be through a middle mile provision. So as we talked about, connecting those regions or those communities together, and then have the internet service provider build that last mile portion of it, or the open access network can build that last mile as well. This model is not new. It's been around. It's much more prevalent in Europe. Sweden is a pretty well-known example of open access networks. And there are companies in the United States that are starting to build these. The best analogy I've been able to find on the internet is the airport analogy. So an airport is owned and maintained by a third party, and the airlines pay fees to be tenants at that airport and allow their planes to land and take off. This is much more cost effective for the airline industry than trying to own their own airports and then restricting access to those airports to only their airlines. Service levels start to drop, and it becomes costly and just impractical. So much like open access fiber, the idea is not to compete with internet service providers. The idea is actually to enable them. And it's also to help enable the community by giving them these broad use, publicly available utility within the public easements to limit overbuilds and limit abandoned infrastructure. A brief just follow up on iFiber. Our founding partners are a couple of Black Hawk Hills Regional Council, North Central and Council of Governments, City of Rockford, NIU, and LaSalle County were the originators as part of this. It's a 501c3, and we serve community anchor institutions, which are largely taxing bodies. However, we also connect healthcare as well. And we are an open access network that has over 13 partner ISPs that use this network. And I think I mentioned that we have over 900 miles of fiber across the northern part of the state. And again, just to reiterate what this model looks like and that it does work. We have been able to prove that this does work, and it does enable smaller service providers to mid-sized service providers to be able to expand their footprint and be able to provide more competition into areas. And this is just my last slide to talk about my thoughts on the future of broadband. So as a big advocate of open access networks, I wholeheartedly endorse a foundational step of bringing more open access networks to the state. This can be done through nonprofits, through local government entities, and even for-profit companies. It just needs to be able to abide by those open access rules. And I think the model that works best is the one that does not directly compete with those internet service providers. From there, we can look at investing in local regional providers, help increase competition and lower switching costs, meaning I don't have to have a high cost to go to a different internet provider because they have to build and overbuild infrastructure to my residence or my building. I can just use that same infrastructure that was built, and it's just a contractual change from my standpoint. We want to ensure that can then be used to help continue conversations toward net neutrality to ensure that services don't get restricted based off of subscription levels or regions. And that also facilitates getting devices to people, education to be able to use it when we have a accessibility. And that's my presentation. So happy to answer any questions either now or after, depending on how we want to do that. And thank you all again for your time.
Thanks, Mark. Yeah, I think we'll do questions at the end just to make sure we try to get through all our presentations. All right. Thank you very much. Over to Steve Schwerbel, and I'll let him do his own bio introduction.
Thank you so much. Yeah, my name is Steve Schwerbel. I am the State Advocacy Manager for WISPA, Broadband Without Boundaries. That means that I work with all 50 state broadband offices to help our members advocate for their needs and talk about what we do at the state level. We stay involved with state level policy discussions kind of across all 50 states. Previous to that, I spent about 7 years in the Wisconsin state legislature. My father-in-law is a big Bears fan, so I come in peace. But I spent 7 years in the Wisconsin state legislature talking about mostly focused on broadband policy up here in Wisconsin. So helping to draft laws related to our state broadband grant program and other issues related to that. WISPA, of course, previously has been the Wireless Internet Service Providers Association. But as I'll talk about in a second here, we are really moving away from that acronym. And we're saying that we are broadband without boundaries because our providers do deploy a pretty significant amount of fiber, and especially in those rural communities that need it the most. So we can talk about that. But we have 600 members nationwide, give or take, and about 18 members in Illinois. Many of those are really small community-based companies that in many places were just not able to get internet service in their community and said, I want to do something about this. I want to fix the problem. And so I'm going to start up a wireless internet service provider, a WISP, or I'm going to start up some approach to finding internet for my community. We also have technology vendors. These are the people who manufacture the equipment that our providers then use, and they're continuing to innovate and find solutions to the problems that our members see on a day-to-day basis. Again, we are Broadband Without Boundaries. We love fiber. We use fiber. You'll never hear me say a bad thing about fiber, but we're focused on choosing the right tool for the job and at the right price and the right amount of time. And so what I kind of want to talk about is how we decide whether we want to use a fixed wireless deployment or a fiber deployment, how that fixed wireless network operates, and what the concerns are or questions might be as you are thinking about technology types to deploy, how you might kind of consider making those decisions. As Robbie alluded to, fixed wireless is a one point. We're on a tower, we're on a water tower, we're on some kind of fixed point. We're not satellite that's kind of flying through the sky. And we're going where it's needed, right? These are just some headlines from some of our member companies who have been making deployments in Illinois specifically. We have many members that were founded in small communities in Illinois, and we have some bigger ones that are partnering with organizations like Microsoft Airband, which is a great nonprofit arm of Microsoft that focuses on digital deployments in the digital divide and making broadband accessible to communities that need it. All of these providers are connecting thousands and thousands of rural and unserved and underserved communities. We are really focused on getting out to those communities that need it the most and stepping into that broadband gap in ways that larger providers sometimes haven't been able to see a return on investment. We're there to make sure that we are stepping into that gap. So how does fixed wireless work? Well, we set the ground really nicely with the previous presentation. I appreciate the technical discussion because that's something that really is important to understand. But we will start from that location and build out. Sometimes we'll do a fiber to the tower deployment where we string fiber over to a tower, and then to get out that last mile connection, you see that point to multi-point down in the bottom left. We're getting the fiber to the tower and then using that tower to deploy out to a community within a radius usually of houses or locations within that tower's site. We'll also do point to point though. And so sometimes we'll start straight from the data center and send that fixed wireless signal kind of from one tower to another to act instead of a fiber backbone. We're using a fixed wireless backbone to connect from the data center to the tower that's deploying the service to a community. So we can serve that point to point access. We can serve that point to multi-point access. And I want to say that we use licensed and unlicensed frequencies. So in certain ways, if you think about this as a radio signal, there are a lot of channels on that radio signal as you're driving down your car. The unlicensed spectrum is just open access. You don't have to be a pirate radio station. Anybody can pop up a tower and start deploying their signal over that unlicensed spectrum. But there's a tremendous amount of technology and network design that goes into making sure that we're not talking over each other. We're not interrupting somebody else's signal. We're not creating noise that harmfully interferes with another competitor's internet service. So we're very, very careful, and we have some really great technology deployments to make sure that if there are multiple operators operating in a certain unlicensed frequency in the same area, that we're not interrupting or interfering with that signal, but that we're allowing everybody to kind of operate seamlessly throughout that space. Licensed spectrum is something that we pay the government for, and we say, all right, I want to operate in this area and I want to operate on a very specific set of frequencies, and I need access to that set of frequencies. And so there are auctions or other ways that you can access that licensed spectrum. It's generally very expensive as an upfront investment, but then you have dedicated access to that space in the frequency channel so that you can use it really without any kind of interruption at all. And then finally, we use that hybrid model where some of it is fiber, some of it is fixed wireless. Sometimes that's that fiber to the tower solution, but we're finding ways to use flexibility and creativity in finding the best way to approach any given solution. And this is not what I say, not your grandmother's fixed wireless in the same way that you think of AOL dial-up as being kind of archaic now, but was cutting edge at the time. Our technology is continuing to grow. There's sometimes a perception that fixed wireless might be slower or less reliable, and that just has not been the case as we continue to develop and continue to improve our technologies. One of our vendor members has rolled out gigabit plus speeds. We are continuing to get through line of sight concerns. Initially, when fixed wireless started, you really had to be able to get a clear sight of the tower that was going to serve you internet. Now we're being able to find ways to penetrate through tree cover, get around line of sight concerns so that we can serve a neighborhood in ways that don't necessarily need quite the same line of sight solution that we needed to have previously. And also performance in all weather conditions. There used to be times when this industry was new that rain or snow might affect the reliability of the signal. That really is not the case anymore. And we found really great solutions and continue to generate new solutions to those problems so that we can make sure to provide that really, really dependable service that we need. This is also a really interesting use case when we talk about the economics of broadband. We know how expensive it is to deploy fiber. You can spend tens of $1,000s per mile burying that fiber in the ground to get it from one place to another place. Fixed wireless solutions offer a really interesting cost-benefit analysis here. Our network deployments can cost about 1/9 of a comparable fiber deployment. And these can be deployed in months rather than sometimes the years that you can take to deploy a similar fiber build-out solution. So all technologies are going to require upgrades and continued maintenance, but fixed wireless offers that upfront cost savings to make sure that you're able to really get broadband out to people now, rather than having that kind of longer build out time frame that you might think of with a fiber deployment. There are a lot of places where that fiber deployment makes a ton of sense, and we're going to use that. But this is something to kind of think about as you're thinking about those networks. So we're cost effective and timely. Illinois is going to get about $1 billion, a little bit north of that, for their BEAD deployment. That's that Broadband Equity Access and Deployment Program, $42.5 billion nationwide, a really transformative, once-in-a-lifetime opportunity to make sure that we're truly connecting every location that needs it in Illinois and across the country. But as we talk about that, we really think it's important. We talk about the economics of it, usually in terms of how much does it cost to get broadband out to somebody. But what we also want to think about is the opportunity cost of delayed deployment. So a community that doesn't have that access now, whether it's the need to homeschool over COVID or do remote learning in other situations, whether it's work from home, whether it's remote healthcare opportunities, what is the cost of having to wait for a project to build out to you that may take 2 or 3 years? We've seen RDOF projects with other funding sources from the federal government take up to 6 years to build out. And what is the cost to a community that needs to wait that full 6 years before they get internet service? Well, that's pretty significant. Can we creatively use fixed wireless to get that first connection now while we have that fiber build out coming? That might be a real consideration for your community if you're looking for solutions. And so as we think about BEAD, as we think about the really incredible opportunities, Illinois has a great state funding program as well, and it's done a lot of work even before this BEAD program has come along to make sure that you're getting out to the communities that you need to serve. What are the real impacts of how we deploy broadband, and how are we using the right tool for the individual job? And are we giving your broadband office, are we giving your policymakers the ability to truly evaluate all approaches to a broadband solution? One of the most important questions that I think is going to be asked of your broadband office and broadband offices across the state is setting extremely high cost areas and deciding how to use that extremely high cost formula to prioritize using unlicensed spectrum, using fixed wireless solutions to really make sure that you're able to invest as carefully as possible and to make sure that you're able to really effectively use your money rather than spending maybe more than you have to on an individual project basis, so that you can fund as many locations as quickly as possible to get that service out there. And that's all I have. Again, my contact information is here. Happy to take questions at the end, but please don't hesitate to reach out if you do have any questions for me at all. I'm more than happy to talk about that. And let me turn off my sharing.
Fantastic. Thank you. All right. I think we'll kick it over to Dwayne Douglas, who will provide his intro and share his slides for kind of a little last mile connection discussion.
I don't have the ability to share yet, Robbie.
Oh, if
Yep, I'm working on that. Sorry.
I've got your slides too, in case we have technical issues.
Okay, Dwayne, give it a try.
Can you see my screen?
Looks great.
Yes.
Okay, great. All right, exploring last mile delivery technologies is what we're going to talk about. This is getting it into the home. Hello, everyone. I'm Dwayne Douglas. I'm the CEO of Quilt, 501c3 nonprofit, and CEO of Node Networks, an Illinois registered electronic telecommunications carrier, ISP, and fiber provider. I have over 25 years of experience delivering scalable and sustainable solutions. My background varies across IT development, telecommunications, healthcare, and others. Since 2017, I've been working in collaboration with communities in Illinois to build scalable and sustainable solutions that close the digital divide. We take an end-to-end approach from connectivity to self-empowerment. And I believe in the advantages and opportunities provided by an internet connection in home. So we talked about broadband a bit there. But what is broadband? So broadband refers to the high-speed internet access that provides users with significantly faster data transmission speeds compared to traditional dial-up connections, if you're old enough to remember dial-up connections. So 25 by 3 sounds pretty fast compared to that. That is the FCC requirement for broadband today. They are looking to expand that and to raise it up. But there's a note that for Connect Illinois for BEAD requirements, we are required to at least have 100/20. Last mile delivery. Last mile delivery of broadband delivery is the final step in connecting to the internet. It's a critical phase that ensures high speed access and service providers to individual devices. We had a graph from Robbie earlier that talked about all the various ways, maybe mobile, fixed wireless, satellite, cable, all connecting to a device. Different technologies use each with its own benefits and its own challenges. DMARC. We didn't talk about DMARC in any of the previous slides, but the DMARC is how it actually enters into your home. It's a boundary where the service provider responsibility for internet connectivity ends and the user's responsibilities begin. And now this differs between a single family home and multi-dwelling environments or multi-dwelling unit environments. In the home, this is actually in my home. I have a typical setup. It's just a modem router. It's wireless and it's provided by my provider at a monthly cost, of course. And you would have one of these, whether you have fiber coming in, satellite, cable, dish, whichever it may be, or DSL, you'd have to have one of these to actually communicate. Now, the providers will at times provide you with an option to bring in your own. However, note that once you put your own router on that line, it's your responsibility. So you call in for service, it's going to always be your fault. So in the MDU and the MDE, the ideal situation consists of a telecom closet where all providers reside with the ability to provide access. Now note, much like Mark was talking about over open access earlier, this is not open access. It's a space where each provider can bring in their services and connect. So then the residents within those units can easily call up for service and be turned up just with a phone call. This closet is in the community of Lincoln Park, which is a nice area on the north side of Chicago. There's a stark difference. This closet is in the Washington Park community. Now, these are varying closets per se. So on the picture on the left, this is where the telecommunications equipment exists. It's on the outside of the building. So they do not have a telecom closet inside of the building. So if you live in Chicago in some of these neighborhoods where you see the wires hanging from your building or coming into the side, maybe through your dining room or your kitchen or one of the bedrooms in your home, this is that solution. This is what's happening there. They don't have space within the property. In this picture here, you can see there's a line coming from the top. That's probably a satellite that's going in through the side of the concrete. And the picture in the middle, this is coming from a pole in the alleyway. All of these lines coming over to this property, going up to individual apartments. Each provider has to bring their own line. So we talk about open access, those type of things, and utilizing shared facilities. This eliminates that. And then on the right side, this is a closet in a newer building in the Washington Park area. This is the telecommunications closet they put in. Connectivity within the NDU. Much like at home, you'll have a typical router in your apartment that you would utilize coming from that telecommunication closets that we just looked at on the prior screen. The property managed ones, these are implementations that we've done ourselves within some of our properties that we work in collaboration with the community and those property owners as well. In the unit, we put a wireless device inside of a central location within the apartment, and we provide wireless access throughout the unit. And then the other one is a property-wide Wi-Fi, whereas we go into the hallways, because in some cases we have to. We go into the hallways, we wire these properties as well, and we provide property-wide Wi-Fi to every resident within there with their own private network. So the private network functions much like this router does as well. They have their own SSIDs and their own passwords. So it's not like in the hotel environment when you go into the hotel just using a shared network by everyone else. You have your own private network. These are some of the speeds that we're achieving at that NDU. And our implementations are both fiber and we implement fixed wireless. And the NDU one I showed you, that's a fixed wireless point to point from a mile away, serving a 47 unit property. So in summary, diverse last mile technologies offer varied benefits and challenges. Urban and rural areas face distinct connectivity obstacles. Broadband is a key to economic education and societal progress. By understanding and adapting these to the technologies, we pave the way for a more connected and equitable future. And I want to thank you guys for your time and for listening to me. And I'll turn it back over. My information is here, Dwayne Douglas at coop.org, to Robbie.
Fantastic. Thank you very much. I enjoyed seeing those images because we don't necessarily in the policy world get up and close to some of those telecom closets, or if you even want to call it that in some of those cases. So it's good to kind of see the wires. Okay, I'm going to just share this kind of screen that has some of our contact info at the bottom here, in case you're just wondering about. Oh boy. Hold on, can people see this? Oh man. Yes, maybe. Hold on. Okay. To just make sure people are aware, you can see all past webinars at that link, and myself or a colleague can kind of share that with you, and we will afterwards if you're subscribed to this event. But all the things are there to reach out to us and if you have any questions. So I didn't see too many questions in the chat, but I will open it up to the floor if somebody has any particular things that they just saw that they would want to ask our speakers right now. No questions. People feel pretty comfortable understanding broadband technologies from last mile through middle mile here.
Hi, this is Ron. I put in a comment about NYC Mesh that they apply this concept of group peering to create inexpensive connections in the community-owned networks. The big players exchanged bandwidth basically for free with each other, and NYC Mesh has applied this philosophy to bringing the peer-to-peer to the last mile. I was wondering if anybody can comment on that.
Anybody want to talk like kind of mesh networking, it sounds like, or if that's what the question is getting at?
About the pricing. That, end users get, charged exorbitant rates that contribute to huge profits for the incumbent ISPs. And they're sharing bandwidth with each other basically for free. And, that's what NYC Mesh is bringing down to the community level.
So this is Mark. I just want to make sure I understand what's asked. Is it a when you're talking about it, maybe eliminating the sharing aspect of the connection, it's more of a direct connection to provide the extent of whatever bandwidth is available is what you're asking, as far as being able to group customers together to be able to leverage that?
Well, instead of a hierarchical network, it's a community-owned network in that they use fixed point wireless. So each household owns the router in their home and the antenna on their rooftop. So they own that node in the infrastructure. So the community has the infrastructure. They're sharing that connection in the same fashion, that, the big players don't really pay each other, for exchanging bandwidth.
It's an interesting concept. I haven't really thought about it from that perspective. We, in order for, and I'll speak from an iFiber operational standpoint. When we connect up, when we connect ISPs and we connect community anchor institutions, we have fees on both sides, and those are, for us to be able to maintain, locate, repair the assets that are in the ground. So we're trying to cover those costs and be able to operate. But as far as being able to divest that, one of the things that we look at is that symmetrical versus asymmetrical connection, and being able to try to deliver that to those community anchors where we can, and provide that more full extent of a port that we can, which given the footprint and the way that we've built it, we're able to move on that. But that's an interesting concept. I would have to think more about it to really kind of see how that could be leveraged.
And Mark, I already wrote down your email address, so I will be following up with you.
Absolutely. I apologize that I can't answer your question. I just want to make sure I can wrap my head around it.
Okay, I think we'll, feel free to interrupt me if anybody has any final questions, but without any that I'm noticing, I just wanted to draw attention to a few things. There's the link that Alicia put in for the next webinar on the 17th. We'll actually be covering updates to the Illinois broadband map. It was previously going to be an environmental review webinar, but I think it's getting pushed to be more timely for a lot of key updates around the Illinois broadband map. So Shubika and Matt Schmidt, I believe, will be delivering that. And then there'll be one more in this track, I think, following in August. So definitely kind of pay attention to that. And so with that, I'll give people back a few minutes of time. There you go. Nancy put the link in there. And I will stay on along with the guests, I think, until the hour, top of the hour, but feel free to return to your days and everything. Thank you very much to our speakers for all this information. And I will work with Nancy to get the slides out on the registration page and everything else. Thank you, everybody. Thank you for your time.
Yeah, I agree. Thank you, Robbie, for organizing this and for everybody for attending. Really appreciate your efforts.
Robbie, on behalf of University of Illinois Extension, thank you for your efforts. Yeah, in the Illinois Broadband Lab. The summer series is going well. And just to kind of emphasize the upcoming sessions, we have 3 more sessions left. One's going to be on August 17th, the next on August 24th, and the third on August 31st. Nancy dropped the link into the chat, so you can all check out registration there. Thanks to DCO, to Benton Institute, to all our partners as we help to educate the folks in Illinois about broadband and its implications for the future. So, and thanks everybody for being here. Just hang around if you've got more questions, as Robbie said, and we'll hope to see you back here soon. One plug for our webinar resources generally, both future resources and archived resources are available at go.illinois.edu/LGE. That's go.illinois.edu/LGE. Hope to see you in future webinars. Thanks.